Good morning friends. Today I am going to explain dot product and cross product. This is one of the important topic in vector analysis. Here we know that what is vector and what is scalar. That is scalar means which has only magnitude and vector means which has both magnitude and direction. Here dot product or scalar product. The scalar product or dot product of two vectors can be defined as the product of magnitude of two vectors and the cosine of the angle between them. Here let us suppose there are two vectors are there, that is along the this direction and this direction, two vectors. Then the dot product will be the magnitude of vector A, magnitude of vector B, and the cosine of the angle between them. So that is called the dot product. So mathematically this can be written as, that is a dot b is equal to modulus of a modulus of b cosine of the angle theta. So under simply this can be written as a b cos theta, where theta is the angle between the vector a and b. So where theta is the angle between the both the vectors. Now I will give some examples for the dot product. Here a theoretical example is, here let us suppose force is a vector quantity, and displacement is also a vector quantity. So we need two vectors, this is also vector and this is also vector. The work that a force perform on an object while causing its displacement is defined as the scalar product or dot product. So that's why the work is considered as the scalar quantity. Here the force and the displacement is considered are nothing but a vector quantities. This is the one of the example, and the another example for the dot product is, let us suppose find the scalar product of two vectors a and b when the modulus of a is 9 and modulus of b is 7 and the angle between the two vectors is 60 degrees. So we have the formula for the dot product is, that is a dot b is equal to modulus of a modulus of b cos theta. So that can be written as already given 9 and 7 are the modulus of a and b, and the angle is also given, that is 60 degrees. So that's why cos of 60 degrees. So this can be written as a dot b is equal to 31.5. So the question will become sometimes like this. Here the another example is also there is, simply find the scalar product or dot product of two vectors, that is a is equal to 2i plus 3j minus 6k and b is equal to I plus 9k. So in this case just simply we have to take the dot product of a and b. There is no angle is given. So that's why 2i plus 3j minus 6k I plus, here j is not there, so that's why 0 dot j plus 9k. So this can be written as, here the coefficient of I is 2. Our coefficient of I is 1. So 2 dot 1. Here the coefficients we have to take, just multiply that one. 3 dot 0, 6 dot 9, minus 6 dot 9. So this can be written as 2 plus 3 minus 54, and that can be written as minus 49. So this is the one of the another example of the dot product. So now we will see the what are the properties of dot product. Here the first property is the scalar product of two vectors, or you can say the dot product of two vectors gives a scalar quantity. So just now I told you that is a dot product of force and displacement gives the quantity work. So work is a scalar quantity, displacement and force is vector quantity. So scalar product of two vectors gives again a scalar quantity. Product may be positive or negative, it depends upon the angle only. Okay, so the second property of this dot product is, the scalar product or dot product of two vectors is maximum when they are parallel to each other. If a and b are to each parallel to each other, and minimum when they are perpendicular to each other. So the dot product will be maximum when the two vectors will be parallel. So here for understanding purpose we can say this one. Here let us suppose there are two vectors are there, a and b. So in between, if angle is what, 0, then we can write cos theta is equal to the 1, and a dot b is equal to modulus of a modulus of b and cos theta. So this can be written as modulus of A dot B cos of that is 0 degrees, then is equal to A dot B. So this is the maximum value. A dot B will be equal to the maximum value when the two vectors are parallel. Now if these two vectors are perpendicular to each other, so when these two are perpendicular to each other means the angle between those, let us suppose this is vector A and this is vector B and this is the angle theta. So now when these two are perpendicular to each other means that is angle theta will be 90 degrees and cos of the angle theta will be equal to 0 degrees. So modulus of A modulus of B, that is cos theta, can be written as here A dot B cos 90 degrees, and this can be written as simply A dot B cos 90 degrees is dot 0, and this can be written as 0. So it means that is when the two vectors are parallel to each other, that time the dot product will be maximum. When these two vectors are perpendicular to each other, then the dot product will be minimum. So just that only I wrote here, that is A dot B is equal to A dot B cos theta and AB cos 0 degrees. So that can be written as AB when theta is equal to the 0. When theta is equal to the 90 degrees, then AB is equal to the 0. So dot product will be minimum. Now this dot product can be written as in the form of I dot I is equal to J dot J is equal to K dot K is equal to 1. Now J dot J and K dot K, sorry, J dot I dot J, J dot K, K dot K I is equal to 0. J dot I and K dot J and I dot K is also equal to the 0. Here this up to this one, this is a scalar product or a dot product. Now we will discuss what is vector product or cross product. So we can write here this term, that is cross product or cross product. So what is cross product? That is the vector product of two vectors. Here this is the vector product of two vectors or cross product of two vectors is defined as the product of magnitude of two vectors and the sine of the angle between them. So in the dot product we have cosine angle. Now in the vector product or cross product, the angle in between the two vectors is sine angle. Here mathematically we can write here, let us suppose there are two vectors are there A and B, which makes an angle theta in between. So that time the cross product or vector product of these two vectors is can be written as modulus of A modulus of B and sine of the angle between them. So here mathematically we can write A cross B is equal to A dot B sine theta and n cap, where n is the unit vector. So there are some problems are there based upon this cross product or vector product. Find the cross product of two vectors. Here A is given and B is given. So the cross product is can be defined as, here you have to take the modulus of this one, in the form of matrices I, J, K. Now A value is 3, 4, 5. So 3, 4, 5 and B value is 7, 8, 9. 7, 8, 9. Just simply take the determinant. All of you know this one, how to take the determinant, that is this column will be vanishes. Then we will get 4 9 ja and 8 5 ja. So we will get the I component like that. J component is vanishing. Then we will get 9 3 ja and 5 1 ja. So like this we have to determine the determinant. So determinant will be A cross B or vector product or a cross product of those two vectors is minus 4i plus 8j minus 4k. So similarly another example is there here. In this in the previous exam just we have only two vectors. In this example we have the angle also. So the two vectors have their scalar magnitude as modulus of A is equal to 2 root 3 and modulus of B is equal to the 4, while the angle between the two vectors is 60 degrees. Then calculate the cross product of two vectors. So the cross product of two, we know that the sine 60 degrees is nothing but root 3 by 2. Modulus A is given 2 root 3 and modulus B is given 4. So when you substitute these values, then we will get 2 root 3 into 4 into root 3 by 2. So this is equal to the root 9 into 4. So this can be written as 3 into 4 is equal to 12. Thank you. For more videos, subscribe my channel Physics.